Welcome to Customer Isolation Lecture in OCI. How do we ensure that resources and services being provisioned by customer are isolated from each other and within customer's own account? So there are two levels of isolation: tenant level isolation and resource level isolation. Tenant level isolation would mean that two customers that might be running virtual machines, these virtual machines might be on the same physical compute host, are isolated from each other. Not only that, these resources should be isolated from any access from Oracle staff and any external threat. So all the security and compliance requirements are met. Now within a customer account, customer might have multiple departments that might be deploying resources in Oracle Cloud Infrastructure. And these resources within the same customer account but belonging to different compartments should be isolated from each other. So to provide customer level isolation on compute side, Oracle Cloud Infrastructure provides bare metal instances. Now these bare metal instances are completely dedicated to a customer and they are not shared across multiple customers. But even in the case where customer might be using VM instances that might be running on the same bare metal instance or physical host, these VMs will be isolated from each other. On the network side, the virtual cloud network or VCNs that are created are again isolated from each other, and we'll look at some more details on that. Even the subnets that are created provide additional isolation of resources running within a VCN. Now, what about data isolation and protection? All data within Oracle Cloud Infrastructure is encrypted at rest and in transit. And customer can bring their own keys if they want to do client-side encryption or can use Oracle provided keys to manage this encryption. On the backend infrastructure side, there is secure isolation between instances that customers are running and backend host. And this is achieved using Offbox network virtualization. Offbox network virtualization basically takes some of the features that are usually implemented in a hypervisor, such as management and I/O functions, and implements them in a separate physical hardware device. So these are the main features that provide tenant level or customer level isolation. Now within a customer's own account, they might need or want to isolate resources that belong to different compartments, and that is different departments, and that is achieved through compartments. Compartments are a logical construct. Every resource created in OCI, compute, storage, anything else belongs to a compartment. And then IAM policies can be written to restrict access of users that belong to a group between compartments. So if a customer has multiple departments, they can create compartments corresponding to these department names. They have users, they can map the users to groups, and then write an IAM policy restricting groups to a specific compartment, thus achieving isolation at resource level. So here is a pictorial representation of compute level isolation. As we can see on the left hand side, a bare metal server basically provides direct hardware access. Customer has full control. It's a single tenant model where no other customer is using this physical server. It completely belongs to the customer that has subscribed to this service. On the right hand side, we have the virtual machine model, and these virtual machines are running on the same physical hardware that is used to provide bare metal service. This is a multi-tenant model where multiple customers might be utilizing the same bare metal server to run their virtual machines, but these virtual machines are fully isolated. Here is a pictorial representation of off-box network virtualization, where you can see multiple layers, VMs running on top of hypervisor. Then you have the host or OS kernel, and then we provide isolated network virtualization, which is very hardened using the off-box network virtualization method. So we looked at isolation at compute level. But what about virtual cloud network and subnets? In OCI, each customer's traffic is fully isolated in a private layer 3 overlay network. Now we can do further network segmentation via subnets. And there are two main types of subnets. Public subnets that are used for instances that require public IP address and access to the internet. And then we have private subnet for instances that do not require any internet access or should not have any public IP address. So now instances can be deployed in two different types of subnets. On top of that, customers can control their VCN traffic, which traffic comes in, and once it comes in, what should be done with that, or block certain traffic. And that is done using security lists, which are both stateful and stateless, or route table rules. So traffic can be controlled through security lists and route table rules. What about traffic that needs access to public OCI services such as object storage? For example, a compute instance needing to do or database instance or a compute instance needed to backup or store something in object storage. The traffic from that compute instance should not traverse the public internet. To achieve that, Oracle Cloud Infrastructure provides Service Gateway, and Service Gateways provide you a path through Oracle's private backbone to reach services, public services such as object storage, so that there is no risk of that data getting spoofed or somebody able to get a hand on the data that is being stored in object storage. Finally, compute instances that are deployed in virtual cloud network or VCNs by default cannot access each other. So as we mentioned, the virtual cloud networks are fully isolated, thus compute instances that are deployed within these VCNs are isolated from other compute instances. But if there is a use case where compute instances in one VCN need access to compute instance in a different VCN, that can be achieved through VCN pairing. And VCN pairing can be done both in the same region or across multiple regions. Now the same VCN pairing feature can be used to provide access to your on-premise network. So here is what VCN and subnet and deploying compute instances in VCN subnet looks like. In this example, we can see a VCN is deployed in an OCI region, and then we have deployed subnets. In this case, we have deployed two subnets in availability domain 1 within this region. One of the subnet is a public subnet, the other one is a private subnet. And as you can see, when we deploy a compute instance or other resources in a public subnet, the main intention is to provide access to the internet. Anything deployed in a private subnet, the intention is that they should not have any access to the internet by default. Access to the internet is provided through Internet Gateway, and as we can see, we can tighten our security control using security list rules and route tables. These security list rules can be stateful or stateless. You can specify the type, either their ingress or egress, and there is a lot of other flexibility in terms of configuring these security list rules and route tables. Now, what about a use case where you have deployed a compute instance or a database instance in a private subnet that does not have access to the internet by default? What if you need to download and apply a patch? In that case, there is a NAT gateway, which can provide access to the internet for a private compute instance or private database instance. Once you have downloaded the patch or whatever else was needed to be done, the NAT gateway can be disabled, and thus the internet access will go away automatically. So overall, you can see the flexibility and the feature set that is provided by Oracle Cloud Infrastructure in terms of providing very, very tight security controls. In the next lecture, we'll look at data encryption.